Hi, everybody. This is the work group device management meeting for July 23rd. And just a few items on the agenda here. Let me pull up the agenda. Okay, to start out, we have status on 131, and that's looking pretty good. Patrick's enormous PR merged, and so yesterday, was it yesterday, Patrick? Today's Tuesday, right? Yeah, yesterday merged, and so that's great news. That's the basic functionality for what we wanted to do in 131. And we have a couple other PRs. One is for quota, device class based quota. And that looks like it's making progress already. And then there's a third PR, which is not really run out of this working group, but a bit more out of the serving working group, but it's relevant to the folks here, which is around getting the resource status into the pod status, and that also looks like it's actively under review. So I'm hoping to see that merge. Anything else you wanted to add, Patrick?
I think we are also discussing something around internal triplet checkpointing, but I think it's not crucial to get it in right now. We just need to have it by beta. So I think that can also go into 132.
Okay. Excuse me. Sorry, Kevin, you're breaking up. Could you say that again?
The check.
Was Kevin understandable by anybody else, or is that just me? No. Okay. Unfortunately, Kevin, we can't really catch what you're saying. If you want to put it in chat, that'd be great. So then along those lines, let's see, am I still sharing my screen? Let's go to the next item on the agenda, which is just the starting to plan for the next release, because there's no rest for the wicked here. The things I put down here are just thoughts that I had around things we could start to work on. Sorry, I have to find my window. There we go. So in 131, this looks like it's going to make it. So originally, I had written this out as if this weren't going to make it, but this looks like it likely will. And then Patrick or Kevin, if you want to add this checkpointing thing in here, if we don't think it's going to make it in 131, we should look at what other criteria we had for beta, but this is what I thought the things we probably need to get done in 132 to, we probably need to at least identify a couple of these. Maybe that's not a requirement for beta. I think it's a good idea for beta. And then there's a whole bunch of things we could do that would be separate caps and likely have separate feature gates. And we should start to think about which of these are important. I think that for me, partitionable devices is probably the most important thing on this list from my point of view. But, you know, this is sort of roughly my order of ranking, but obviously it's not up to me. So I wanted to get folks thinking about this, and you know, if people need clarity, we could go through these either now or in a future meeting to kind of talk about it and get feedback from the folks interested in this about which things should take priority. But that's really all I wanted to talk about today. So I'm just going to open the floor to anybody else that wants to discuss any of these things. And if nobody wants to say anything, then we can all.
I have a question. So are we going to discuss the scoring functionality um,
Great question.
around? Yeah.
There is no scoring right now. We take the first solution that we find. So why don't we? That's accurate, right, Patrick?
That's correct. We do backtracking. So if making a bad choice for one claim or one request in one claim doesn't lead to a solution, we keep checking other alternatives. That is a change compared to 130. But then once there is one device for each request, we stop evaluating and checking options and just use that solution. There's no
I see.
concept of looking for a better match between requests and devices because we don't know what better means.
Yeah, but that's one aspect. Part of my question was also, the interplay with the Kube scheduler plugins, right? I mean, there are handful of or couple of plugins that can, score nodes based upon what they think. So, is there any integration with that, or does it cause any issues when we have something separate implemented for device structured parameters versus the old way of doing things is the Kube scheduler plugin? I mean, that was kind of the question around integration of both these two scoring mechanisms.
So node scoring should work the way it always did. It's just that the dynamic resource claim or dynamic resources plugin in the scheduler doesn't contribute to the node score. It doesn't do scoring itself. So if one node has a better device than some other node, that is not something that's currently that's currently reported to the scheduler, and it will just pick one node basically as far as devices are concerned arbitrarily.
Okay. I mean, sorry, one last question. So maybe this ties to what John was asking about the partitionable devices, and I mean, I'm having hard time to understand, how would node scoring be a pass when, a slice on a device on a node cannot be accomplished, right? I mean, this node scoring does not have any insight into if a slice is valid or not. Still it may score a node as valid. So then how does the entire machinery work is a question to me.
So I think that the fit is calculated by the plugin, and so you will only it's more that you can't differentiate between two nodes based upon their devices. So we'll pick the first solution for a node, and if there's no solution, we'll say there's no solution for this node, and so that node is no longer under consideration. It's just that if you have 10 nodes and something fits on 5 of them, then the scoring aspect won't include, in this case I get, a better device than in that case for some reason.
Okay, I mean, I'll put some thoughts around it and share a doc if that makes sense, and then you can comment.
Yeah, that would be great. And we can, and it's something we can implement. It's just not in 131, right?
Yeah.
Mhm.
Yeah, got it. Yeah.
So Rita has a question in the chat about autoscaler implementation. Sorry, Doug, 1 second. So I don't recall if we have a document about that. Kubo from the autoscaling SIG was going to look at that a couple releases ago, but because so much change has happened in 131, we just deferred that. I think now we can revisit that with him. I mean, there was, Patrick, do you have more to say about that? I don't think there was a doc per se, but there was a lot of discussion just on a PR at one point.
I think it was in the CAP PR where we discussed the plan, and there is also something in the CAP itself, I think, that outlines an approach. The discussion basically says that we are making the plugin as it stands right now in the in-tree implementation stateless. So whenever you instantiate it, you need to pass it a resource claim cache, and based on that, it will determine what's allocated. And then some autoscaler implementation can basically control the state that it gives to the plugin when it does simulation. Of course, that only applies to autoscalers which actually use that plugin. Something that is out of tree and doing its complete own thing just has to re-implement the logic around device selection, device constraints, and, well, figure out what a good node to create would be.
Okay, thank you. Doug?
Question. Partitionable devices versus fractional devices. Is this like slicing a GPU versus SRLV VFs or kind of thing? Or what are you thinking here?
So partitionable, that phrase to us means effectively hardware layer partitioning. So from the point of view of Kubernetes control plane, it's presented with multiple devices, and there's a functionality built into the way those devices are modeled such that if the scheduler chooses one of those devices, not only that device is removed from the list of options for future scheduling, but other devices that are related to it maybe. So the canonical example is NVIDIA MIG. So if I pick the first memory slice, I can't get other configurations. Google TPUs are the same way. I can pick a certain topology. So I can pick TPU 0 and 1, or I can pick, but that means then I can no longer get a four TPU unit of 0, 1 through 4. I can still get 5 through 8, but I can't get, or 5 through 7, but I can't get 0 through 3 or whatever it is. You get my point. So that's partitionable. So it's kind of it's implemented at the driver level. Now fractional is more like, okay, as a user making a claim, I want 8 gigabytes of GPU memory. Now, Kubernetes as a platform knows that it's got a bunch of GPUs ranging from, 4 gigs to 64 gigs, but it's going to give you a 64 gig GPU, but it's going to be in sharing mode such that other unrelated workloads can get a subset of that GPU. So right now, this isn't, the reason this is fairly lower in priority is that it's not really well implemented at the GPU layer, right? We don't right now, and Kevin can give you much more detail than I can, but right now, for example, this is managed by CUDA, and it's managed like you need the same Unix user ID in order to share these, and the memory boundaries aren't super strong. And so like the idea of having the platform sort of multi-tenant and divide up these GPUs in the same way we divide up CPU or memory on an ordinary node is fraught with all kinds of issues. So, but that's the idea behind the fractional GPU or fractional device there, is that it's more from the claim side. I don't want a whole device. I'm willing to take a partial device and share that device with other people. It's different from MIG, which simulates whole devices. So there are two different approaches to fractionalizing a physical device, but MIG is constrained in certain ways and fractional is constrained in other ways. That makes sense?
Yeah, I appreciate that explanation a bunch. That totally clears it up. Thank you.
Sure. Any other questions? And suggestions for, so it doesn't have to be now, but think about it. Like scoring is something I didn't put on that list, but please, we're going to start this process of planning. So maybe for the next call, we'll do a little more in depth on this. We'll go through each of these and what those of us who've been spending most of our time on this have been thinking about with each of these, and get feedback from everybody else. But this gives people a chance to start to think about it. If there's nothing else, let's wrap it up and get some time back today, especially on Code Freeze Day. Oh, Sam P. Yep.
Hi, this is Sampath from NTT. I have a quick question about the, I think it's Doug's entry for the future meeting agenda, network status for multiple network cases. Actually, could you please elaborate on that point? Are we going to discuss it?
Yeah, so here's this, so here's generally how this works from my perspective, which is kind of a multi-networking focused, but in a multi-network scenario today, so say if you were to use network attachment definition and multi-CNI, once the terminal CNI plugins run, Multis collects the CNI result, and then Multis creates what we call a network status annotation, which has kind of the results of what happened. So if you've got some kind of a workload that needs to know some information about the networking for it in that case, it's able to get that through the downward API. And I wanted to bring this up here because we have some of these use cases here. And I mean, even like the first example that John was giving me was like, you really, in some cases, may have like a stack of devices, which may include an SROV NIC. So I was thinking, is something like this useful here? I can see where it could be very convenient from the workload standpoint, and I'm not sure if some of these other workloads that I'm maybe not as familiar with might also benefit from this kind of information. So I wanted to hear from the group what folks thought about that in particular. So that's why that was there. Thanks for bringing it up because I keep meaning to chat about it in this
Oh,
call.
no worries, no worries. I've been interesting about this topic, and I think me and my colleagues had a few use cases on the document about multiple network device interfaces, and especially the device with the network interface like FPGAs and the GPUs which has the NIC on board. So we are so much looking forward to enable those network interfaces as a secondary network interfaces for communicate between devices. So yeah, I'm more than happy to give more information and use cases for.
Yeah, we'd love to get that. Let me tell you what we've been thinking about that so far, and we can see if that's sufficient for what people think, or we definitely use more feedback on this, right? Or more use cases, more feedback, more detailed feedback, more detailed use cases would be awesome. And even like, right, we talked last time about driver implementations. Like if you've got some special devices, we should try implementing drivers, and I'd be happy to work with anybody who wants to implement a driver for their devices or for a device of some vendor that they use and need. Reach out to me on Slack or just on the channel and just tag me. And like I would love to work with people on that. But anyway, the point is, what is it we have talked about doing? So in 131, we did not add put it this way. We talked about in the beginning, we would add a status to the resource claims, and that status would be able to be written by the driver to store the allocations or whatever data, really arbitrary, like raw extension data, that the driver needs in order to communicate back to its workloads what it's done. And we didn't do that in 131 because we already had too much scope and there were too many open questions on it. So we delayed it. So in 131, the strategy would be to create a custom resource and store your allocation in that custom resource. Now that doesn't help with downward API per se. You'd actually have to have a workload that's going to read that custom resource out of the control plane. So that's a little bit painful from that point of view, but that's what we have in 131. In future, as we go to design 132, one of the additions that we could do would be what I just described a minute ago, which would be that resource claims get a status, and that status could be written by the driver. And in the general case, that's a raw extension, meaning it's arbitrary structured JSON data that can be written to that field and read out. And we'd have to, if we wanted it exposed by the downward API, we'd have to do that. I assume that we could do that. On the networking side in particular, we did talk about that. We know that, for example, for SRIOV, we don't want individual drivers to come up with their own schema for storing like the results of IP address allocation or whatever. And so we did talk about the networking group coming up with some sort of structure that could be stored in that status to, that would be standard across different network interface driver, DRA driver implementations. So that's our thought process. It's not final in any way, so that's definitely something we should put on the agenda for 132. It sounds like there's a lot of interest there. Does that help?
Of course, yeah. Thank you very much. Like, I think we should discuss more about the how to proceed with this one. From my point of view, I think it's a bit of we have discussed a lot more before we jump into the implementation part. So
Sure.
I think it's take time. Yeah. So, of course, I would like to contribute on this area.
Excellent. Great.
Thank you.
I'm adding another KEP to this list. So what I'm going to ask maybe for next time is people, well, next time I'll copy this into the next thing and we'll say, well, assuming nobody else has agenda items for next 2 weeks from now, we'll actually take these and we'll go through them and we'll explain what each one is. And we'll try to start that process of getting feedback. Maybe they'll go to alpha in 132, maybe not, but at least we'll start developing and refining what the contents of each of these standard network interface data. All right. Awesome. Okay. Yeah. Good. Thanks for bringing that up, Sam, because I know I forgot to move it down from there. But I'm glad Doug was here to explain. Varun.
Hey, John. So I had a use case that I wanted to share. We maybe touched upon this briefly in one of the earlier meetings, but I was looking for a download API on the pod to be able to publish some device attributes as an variable from the DRA driver.
So you have a use case where you want to publish, you get assigned the device by the scheduler, then in the downward API, you want to be able to expose a device attribute. Yeah, I think we talked about this in the past. So, I mean, that sounds useful. Did you want to go into detail? Did you have a specific use case, or you just want to make sure this gets on the board for planning next?
Yeah. So our biggest use case is that once we assign the GPU device to our pod, we do want the pod to understand what the PCI device, the bus ID is, or the domain address of the GPU itself that was allocated. And then we have so for KubeVirt, the open source project to deploy VMs on Kubernetes, one of our use cases is that for the pod where we allocate the GPU, the pod needs to understand the PCI address of the GPU so that it can actually define the VM using that.
And this is, I think we did talk about this before. So I think the question then was, is that we have we use CDI to implement this. So the question was whether CDI was sufficient, and I think you were thinking because of the extra layering in KubeVirt, it may not be.
Right. So the problem is like understanding the CDI spec to know which device node corresponds to the GPU that I requested is not going to be easy.
Okay. So let's, I think Kevin dropped. I'm not sure I have enough knowledge to give you a good answer on any of this, but how do we want to proceed? This is my question. So we can put this on the, we can put this on the, what am I trying to say? On the board for, hey, let's start investigating this in the 132 timeframe. I mean, I think the first step you can take, if you haven't done so already, I didn't look, but go to that that use cases document and kind of make sure that that's included there. I can put it on this list that we're just looking at as something to be. I don't know if it'd be a separate cap or it'd be just I don't know, but I'll just put it that way for now. Downward API access to device attributes. For example, for KubeVirt. You can correct this, make it the bus ID or something. Yeah, awesome. So that's another, so you can see there's already a long list, right? So let's maybe, yeah, any other, I think the next step is over the next few meetings and the next, as we go into 132, to look at each of these, see if somebody wants to own it, and kind of try and carry it through. I think it's, there's enough work here for far beyond just, the couple of folks that have been spending most of their time on it. So let's, yeah, awesome. Thank you. Is that good? Did you have more I can help you with on that, Varun?
No, that's good. Thank you, John.
Sure.
So,
all right. Anything else? Okay. Well, thank you, everybody. What we'll do is, like I said, next 2 weeks from now, we'll plan to go through this list and detail what each of these means from the what we've learned over the last release or two, and start the discussion on what we think is priority as a community to get into 132. Obviously, beta is the most important thing of all those. So, all right. Thank you, everybody. You have a great day.
thank you. Bye-bye.
Thank you. Have a good day. Bye.